Have you ever seen a metal chain act like it has a mind of its own? Look at this incredible arch as it leaps from the cup. It seems to defy the very laws of gravity that we deal with every single day. But what is really happening here? It's not magic, and no, there aren't any hidden magnets. This is a real physical phenomenon called the Mould Effect. Named after Steve Mould, who popularized it, it looks like a glitch in the matrix of our reality. To understand why the chain leaps, we have to look closely at how these bead chains are actually built. Most people think the chain is just being pulled down by gravity. While that's true, it's not the whole story. Gravity alone doesn't explain why it jumps upward.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
By physicists John Biggins and Mark Warner in the Proceedings of the Royal Society, found the answer. They discovered that the secret to this amazing fountain lies in the specific stiffness and structure of the links. You see, a bead chain isn't perfectly flexible like a piece of silk thread or a soft piece of yarn. It's a sequence of rigid segments. This rigidity means that when one end moves, it forces the other end to react. Imagine a single link of the chain resting in the cup. As one end of this link is pulled up by the falling chain, the other end of that same rigid link is forced to rotate downwards as it pivots around its center. This rotation makes the bottom end of the link push down against the pile of beads or the bottom of the cup. Think of each bead link like a tiny seesaw. When you pull one end up, the other end naturally wants to go down. But because the link is in a container, it hits a solid surface. It can't go through the bottom of the jar. So it pushes against the jar, and the jar, following Newton's third law of motion, pushes back with an equal force. This upward reaction force is the secret kick that launches the chain into the air above the cup. That upward kick is what provides the extra momentum needed to overcome gravity and create that arch. It's a constant stream of tiny mechanical boosts, happening thousands of times every second as the chain flows. If the chain were perfectly flexible, like a piece of silk thread or a cotton string, there would be no arch at all. The string doesn't have the rigid structure needed to push down and get that upward kick from the container. But these beads are rigid segments. They need a certain amount of physical space to turn around the corner. Because they can't bend instantly, they must follow a curved path, which creates the beautiful arch we see. This turning force, combined with the kick from the base, creates the momentum needed to maintain a stable loop. It's a literal mechanical kick-off that keeps the chain hovering in space, defying our usual expectations. Now, watch what happens when we increase the height of the fall. If we drop the chain from a tall ladder, the arch gets higher and higher. This is because the faster the chain falls, the more energy it has. The faster the chain falls, the stronger the pull on the links, and the harder those links push down against the floor. A harder push means a stronger reaction from the jar, and the arch climbs higher to balance the energy. It's a perfect loop of energy. The potential energy of the height is converted into kinetic energy of the fountain. Science shows us that even a simple pile of metal beads is following strict, beautiful mathematical laws. The interplay between torque, tension, and momentum is what makes the Mould Effect so fascinating to study. Physicists are still exploring the fine details of this phenomenon, proving science is everywhere. Now that you've seen gravity get a little bit confused, what other everyday objects behave weirdly under physics? Perhaps there are secrets hiding in your kitchen or your toy box that are just waiting to be explained by science. Let us know in the comments if you've ever tried this experiment yourself or what you want to see next. Don't forget to like and subscribe for more deep dives into the hidden physics of our world. Thanks for watching.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.